Okay, so next up, we've got Kaan Uzdogan from the Ethereum Foundation, who works on the Sourcify project. And he's going to tell us about human-friendly contract interactions with Sourcify verification. Let's welcome him on stage.
So, hello everyone. My name is Kaan. I'll be talking about how we can enable human-friendly contract interactions today. So I'll start with something that we are all familiar with. So just a normal day in Web3. And this is something a typical Web3 user see every day. And it is this. So every day you are greeted with these bytecodes, byte strings. You have no idea what's going on. Like, am I doing the right thing? Am I talking to the right contract? What am I doing? And this is just equal to saying, just shut up and take my money. I don't care what you're doing. Just, I'll sign this, whatever you say to me. And this is what we like to call YOLO signing. So still, a typical Web3 interaction is a YOLO signing nightmare. They just give us things to sign, and we just sign them. So ideally, what we want to have is from something on the left that machines can read to something on the right that humans can read and understand. And how do we do this? There are several components, several building blocks to this. One of them is the source code and metadata availability. We will walk through all of these. The second thing is the perfect verification, source code verification. Next, there is the NatSpec documentation of contracts. And we also need, most importantly, wallet and block explorer integrations. So first of all, this whole thing is built on top of Solidity contract metadata. And who knows what Solidity contract metadata is here? Maybe. Can I see some hands? OK. A decent amount of people, more than I expected, but still not the majority. But that's why I'm here. So the metadata is the output of the compiler. It was actually introduced in 0.47 quite a long time ago, but it was not really picked up by the community. And it's a JSON file generated by the compiler, which contains metadata. But what does metadata mean? It has the ABI, the user doc, which these two are concerned with how to interact with the contract. And the next two is compilation information and source file info. And these are about how to reproduce a contract compilation. And the file looks like this. It's a JSON file, as usual. You have the language, you have the output, the compiler settings, and additional information about source files. We will dive into those shortly. And the next step is the source code verification. So if you have been in the space for a while, I actually don't need to explain why you should verify your contracts and why your contracts should be publicly available and transparent and auditable, etc. That's something already we know. But let's have a look how this is done actually and how the Sourcify verification works differently than the usual, the common one, let's say. So the problem is here that machines understand bytecode. They don't understand the code we have written in natural language. And the problem is here, how do we make sure just a random code you see on GitHub or somewhere else is actually the contract that is running on the blockchain, right, that is I'm talking to? And this is how it's done in a really high level. So you have the source code, you have the Solidity files, and you also have a compiler. You have a compiler and its settings such as optimizers, or there are many settings on the compiler. And we feed them into a Solidity into the compiler, the version that we have. And we recompile it. So the contract is already deployed. We have these files that we want to verify, and we feed them into a compiler. Then the compiler gives us a bytecode, the bytecode of the contract. Then we have the contract that we want to verify, say at this address. Then we get the contract's bytecode, and then we compare these two bytecodes. If they match, then we say, OK, this source code is actually the original source code of this contract. I mean, there are more details to this, but on a high level, this works like this. But the verifiers are actually leaving out some of the bytecode. So the common way we verify contracts today is leaving out some of the information deployed on chain. And they are specifically leaving out what I call aux data. And aux data is this field at the end of the bytecode. So you might not be familiar with this as well, but the Solidity compiler by default appends some additional data to the contract's bytecode. Like, apart from the functional part, you have some additional information that comes in handy when we are verifying contracts. And this is well defined in the docs. You can check it out there. So what we call partial match is the match without this information. It's when bytecodes match. And the perfect match is when bytecode plus the aux data match. And the perfect verification with the aux data cryptographically guarantees that the whole compilation is exactly the same as deployed. Like, even the comments, variable names, everything is the same as the original. Even if we add a comment, add a space, add a dot, the perfect verification will break. So here we can say aux data is more or less a compilation fingerprint added at the end of the bytecode. And how does this work? So again, when you are compiling your contracts, you have, say, these files. The compiler itself hashes these files. It takes the inputs and gets a hash of these all files. And we talked about the metadata file. The hashes of the source files are embedded here in the metadata file, as well as the other ones. Then we take the hash of the whole file, in this case, an IPFS hash by default. And then this IPFS hash is embedded, encoded here in this file, in this appended data. Then, when comparing bytecodes, if these match, we say it's a full match or a perfect match. So let's see what happens when we make a difference, when we tweak a little, when we make a little change in the contracts or in the compilation settings, or in this case, the contracts. So let's say I added a line of comment in my code, and now I have my contract -diff. Now the hash changes. Obviously, the hash and the metadata will change. Then this hash will change. And when the hash of the metadata will change, this field will be different. And then, when we are comparing, this won't be a perfect match, but this time it will only be a partial match. So this is the way that is commonly done today in the ecosystem, like on the Etherscan. This field is left out. And what we have is completely partial matches in the ecosystem now. And let's take a look what's inside this aux data. So this green field, when we decode this section, it's actually CBOR encoded. And when we decode it, it has the IPFS and the Solidity version. So again, if we further decode them, the Solidity compiler version in this case is 081. And the IPFS hash is as follows. Like, this one is in hex encoded, this one is IPFS coded. And if you are more curious and want to see this in action, we have a playground at playground.sourcify.dev. And here we also have provided some example contracts that you can check. And even if there's a contract that is deployed, you can get the address and see how the aux data of this contract is working. OK, so we saw how we can verify. But if you, as a user, want to verify your contract, how can you do this? So we have the Sourcify UI. You can, in this UI, provide us the source files plus the metadata of the contract, then give us the address and the network the contract is deployed in. Then we can try verifying the contract. And we also have many networks, not just Ethereum networks. I think right now close to 30 different networks. So if you have an EVM network, you can also have Sourcify verification. But we actually highly encourage you to run your own Sourcify instance, because the Sourcify is an open source project, and we don't want to be the only source of truth. And we highly encourage projects to run their own Sourcify instances instead of relying on us. We also have an API, so you can programmatically use the Sourcify API, and this you can also find in docs, documentation, docs.sourcify.dev. Yeah, we have several different API endpoints for verification or as well as fetching contracts or getting the file trees. Then we also have some tooling. We also have a hardhat plugin, so it's called hardhat deploy. And if you have deployed a contract using this plugin, you can just say hardhat network mainnet or any network and Sourcify, and the plugin will verify for you. We also have a Remix plugin. If you deploy your contracts using Remix, then you can go to Sourcify plugin, select your contract, give us the chain and the address, then the plugin will verify for you. Now we also recently have Foundry support. So using these commands, you can also, by changing the verification provider, you can also verify your contracts on Sourcify. We also have something called monitor, which does automatic verification. So what this does is actually the monitor listens to the blockchains. At the moment, we are listening to Ethereum blockchains, like the mainnet, the testnets, as well as some rollups. And this catches the contract creation. So whenever we find a contract creation, we again look at the metadata hash, and it tries to fetch the metadata file from IPFS. If it can, then it will try to fetch the source files from IPFS. Then it tries to automatically compile and verify everything. So that means if you publish your metadata and your source files, then we verify for you. So you don't even have to come to us and manually verify your contract. We'll just listen to the blockchain and just verify it for you. The only thing here is you have to publish, I think, in 5 minutes or so. So either deploy time or just right after deploying. You also have a contract repository where we have all these verified contracts. We serve this over repo.sourcify.dev on HTTP as well as on IPFS. And we have this under an IPNS that we update regularly. So you can go to IPNS repo Sourcify.dev, and it is structured as so, like contracts, full match, partial match. Then you can give the chain ID and the address of the contract. This is the same structure in the repo.sourcify.dev as well. So there is one more piece in the puzzle until we get to the human-friendly contract interactions, and that is what we saw here. So I actually didn't speak much about the user documentation and DevDoc, and this is the documentation that is coming from the NatSpec. So let's go actually. So NatSpec is a specification in the Solidity documentation, and it's the rich documentation for functions, return variables, and it's named the Ethereum Natural Language Specification Format. So if you are familiar with JSDoc, it is similar to that, and it has several different fields that you can use, as well as custom tags. And if we look at a function, in this example, it sits on top of the function. So in this case, the swap owner function is our function. Then we have the developer documentation here. Then we have, at the notice field, we have the user documentation. Then we have the documentation for the parameters. So where does it come handy? So let's take this user documentation of this function. So this is a swap owner function, and it says it replaces the owner, old owner, in the safe with new owner. So this is what your users are going to see. And the NatSpec has this handy specification called dynamic expression. So if you have these backticks and a variable name, then you can take the variable names and fill them dynamically. So if your function is called, for example, with these addresses, the old owner this one, new owner this one, so you can dynamically show the users actually the whole addresses. OK, then we did a NatSpec, And finally, to get to the users, to get to the end, we need wallets and block explorers and their integration. So what can a wallet do? When your users are talking to a contract, you would get its bytecode and fetch the metadata, fetch the IPFS hash, fetch the metadata's IPFS hash. Then in the metadata, as you recall, we had the ABI and the NAT spec. And using those, hopefully, you can show users something more meaningful instead of this. So the argument section, you can decode with the ABI from the parameters of the function. And if there is a NAT spec, well-documented NAT spec, then you can show the users what this actually does. For example, this would register the domain for 1 year. But this is not only the way, not the only way to human friendliness. This is one approach we are taking at Sourcify, and it's worth mentioning the different takes, I think. So there is also, so the idea behind Sourcify is using the NAT spec and the metadata. The other approach is EIP 4430 and EIP 3224. The idea behind this is to have a describer function inside the contract. So if you call, for example, the EIP describe function, decoding will be done inside the contract, and it will be returned to the user as well. The nice thing about this is it can decode things like ENS commit, because we can't decode the ENS commits as it's a hash that is committed, but the information is also already inside the contract. So it can decode things like this, but obviously you need extra gas for the contract. The second one is the EIP draft recently by Dan Finley. And here the idea is to approach the user at the first point of contact. So whenever they have an interaction, you just give the user the information. So this is backwards compatible, and it's more flexible, but there is no verifying thing. So it's not either in the contract or it's not hashed that we can verify. And we can do better. Like, there are many more ways for a better UX. Like, we can warn the users when there's a large amount. We can warn for large fees. We can show the user how many times the contract is interacted with, because a scam contract would be less used. Or we can say when it's deployed, because a scam contract would be more recent. And importantly, we can show the users if this is audited or by whom. So there are many ways to do this. And as a recap, let's say technically Sourcify is an open source automatic smart contract verification service. It has a user interface. It has an API. We have different tooling to verify contracts manually. We also have a public decentralized content address storage of verified contracts, which is our repo. And more generally, we are a base layer and public good for other tools to build on top of. Also, we are an initiative to use more Solidity metadata and NAT spec, and we are an ongoing effort to improve smart contracts UX and safety and transparency. So thank you, and if there are any questions, I would like to answer those. Any questions? One over there.
So if the contract verification fails, do you provide some meaningful errors about why it failed, or is it just like, no, didn't fail?
Depends. Like, if it's failing because your file is missing, we say that. Usually, I think when there's something that we can say from the compiler, we forward this to the user, but obviously that's something technical. But yeah, it's usually the case that it's fails because a file is missing, or we can't, for example, get the bytecode. So we try to do that, but I can't say we do it all the time.
Okay. Thank you.
Is there any way to decentralize the admin rights, like so that it's not in control of just a single dev, but maybe a DAO?
The admin rights of the application? The Sourcify, you mean? At the moment, we are welcoming contributions. but so far it's mostly the people working on the project that is developing. I hope actually it evolves in that way so that we can actually decentralize this whole thing. But at the moment, it's mostly built by a bunch of people.
I think this is all really great work. I was wondering, maybe you have any ideas on why, as you said, these standards, the metadata hash and the IPFS and so on and so forth, and the NAT spec, they've been there for a very long time, but they haven't got massive adoption from wallet providers, etc. I was wondering if you maybe know what the reasons might be or what we might do to change that.
Yeah, I mean, it's a chicken and egg problem. The less, it's like the more it's used, then the more people will get aware of it, and it gets more used, right? And I think the problem, like the bottleneck, is here at the tooling, developer tooling. So Etherscan has been, and the partial verification has been the first comer, and that's the de facto standard right now. And it's really difficult to change people's habits to how they do things. And we really need to make this more seamless and raise more awareness to do that.
Yeah, getting people to understand what they sign is, of course, very important. But you mentioned like showing variable names. That's something that can easily be abused to try to actually trick people, rather than being, them signing something binary which they don't understand. They can actually be deliberately misled by, falsely named variables, which is what would happen. Do you have any thoughts about how to, not just show names that actually tell people what the contract does? Is there that kind of a level to this?
I mean, obviously, the assumption we are making is the contract is benign. So we actually assume we trust the contract author. And if the contract author documents the contract well, then we can show actually the correct messages and good variable names, etc. But as I said, that's why we need the other things. We need the audits, we need the other information that users can inform themselves better. But at the end of the day, the anchor point is the developer. Whatever developer says, we say it's OK. What you say is this.
OK, we still have the time for 1 or 2 questions.
How can projects integrate Sourcify?
We have an API. So we have the documentation of the API. Obviously, you can check that. We can also just approach us. We have a public chat, or just find us on Twitter. Maybe I'll go to this slide. Yeah, maybe find us on Twitter. Just approach us. We are happy to help you guys.
Thank you so much, Kaan.
Thank you.